So here we have a table, and it looks kind of daunting at first. What it is, it's all of the degree values from the unit circle that we really have to have memorized. It starts at 0, it moves up through 30, 45, 60, 90, 180, 270, and 360 degrees. Now we already know from our conversion factor that 180 degrees is exactly the same as pi radians. But now we want to learn some of the others. I think earlier we converted 45 and found that it was pi over 4. Okay? 30 degrees, if we convert it, turns out to be pi over 6, and 60 degrees turns out to be pi over 3. The way I kind of keep that straight is I say, okay, 45 is over 4, 30 is over 6, whereas 60 is over 3. So we know that those 30 and 60s kind of always play off of each other. So that seems to be, pretty easy for most people to figure out based on the unit circle points. So there are your first ones. 0 is still 0, except notice that 0 radians doesn't have a unit mark. That's how you know the difference, whether it's 0 radians or 0 degrees. The degree will have the degree symbol, but the radians won't. So 0 is 0, 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, and now we want to move over here to 90 degrees. 90 degrees is actually, 90 is half of 180, and so 90 degrees is actually half a pi. So every 90 degrees you go up half a pi. 180 degrees we already know is pi, and 270 degrees is 3 pi over 2, or 1.5 pi. Finally, 360 degrees is 2 whole pi's, because 180 times 2 is 360, and pi times 2 is 2 pi. So that's how we move from degrees to exact radians for the unit circle angle values. We also included on this chart some approximate values, simply because I think it's good for your just number sense to kind of recognize them. 0 is just 0. But pi over 6 turns out to be about 0.52. And that should make sense to you because pi is about 3.14. If you divide it by 6, then that's, about a half. And if you're not sure, you can always look in your calculator. So if we take a quarter of pi, it turns out to be about 0.79. And you don't really reach a whole radian until right around 60 degrees. It turns out if you work it out, the conversion factors, and use it to find what 1 radian is, it turns out to be somewhere around 50. I guess we could pause for a second and figure that out. Okay, so it turns out to be, if I take 1 radian and I convert it to degrees, 180 degrees over pi, that turns out to be about 57.3 degrees. So you can see that's why 60 degrees is so close to 1 radian. You would think I'd have that memorized by now, but I think every semester I have to go figure it out. All right. 90 is about 1.57 because it turns out to be half of pi. Whole pi we know is 3.14 radians. 1.5 is about 4.71, and you don't really reach 6 until really close to one full revolution to 2 pi. So it's 6.28. So those are the ones you need to have memorized. So you really need to start working on those and getting familiar with those. The easiest way to learn them, though, is probably not in table form. It's probably in unit circle form. So let's, on this next slide, I have a blank slide, let's take a look at it and let's draw out the unit circle as we know it so far. Not put the ordered pairs on yet, but let's just put on the degree measures and then go through and see how many of them, we can talk back through and make sure we know to convert to radians. Okay, so I'm starting here with just kind of a blank slate. And I'm going to draw a unit circle in it. So I'm going to start with my x and y axis system. All right, and I'm going to put in a mark for 30, 45, and 60. I'm going to go ahead and label these all in degrees. So we're going to say 0 degrees, 30 degrees, 45 degrees, 60 degrees. This one is 90 degrees, 180 degrees, 270 degrees, and this all the way around would be 360 degrees. Those are our degree measures that we've had memorized since pretty much almost the beginning of chapter 1. Now let's go through now, and in blue I'm going to label the radian values. Well, 0 is 0. 30 we talked about before is pi over 6. Think of it this way. 30 times 6 is 180. And if 180 is equal to pi radians, then that should be pi divided by 6. So pi over 6. 45 degrees goes actually into 180 4 times, and that's why it's actually a quarter of pi. 60 is pi over 3 radians. And 90 is exactly half. It's halfway between 0 and 180. If 180 is pi, then 90 is pi over 2. So it's half pi. 270 degrees turns out to be, check this out, every 90 degrees is half a pi. So if I start from here, I'm at 0. If I make it all the way to here, I have half pi. Here's another half, so a half and a half is a whole. And so this one's going to be 1.5 pi in terms of radians right there. But instead of writing 1.5 or 1.5 pi, you know, we're math people and we really like those fractions rather than decimals because we know it's exact and hasn't been rounded. So we're going to mark it as 3 pi over 2 radians. And then 360 degrees is 4 halves. It's 1 half, 2 halves, 3 halves, 4 halves, which reduces to 2 pi. So this is 2 pi radians. And so far, that's all we know. That's all you really have to know from memory, so to speak. But there are some other things I want to build with you. We're going to take it quadrant by quadrant. We're going to come over here. We're going to add 3 other spots in quadrant 2. We're going to put 1 here, 1 here, and 1 here. And those are going to apparently not be very straight, but that's okay. Those are going to be our unit circle points that we don't have memorized, but that we know have the same, basically the same ordered pairs and the same reference angles as the ones we do have memorized. So this guy right here has a 30-degree reference angle, which would make him 150 degrees. This one has a 45-degree reference angle, just like this one. They're sort of like reflections around the y-axis of each other. And that would make him 45 less than 180, so 135. And finally, the upper one here, the one furthest away from the x-axis, always has a 60-degree reference angle, giving it a measure of 120 degrees. And so there are the 3 additional points that exist out there, or the 3 additional angle measures that exist out there. Now, notice that I have not yet put the ordered pairs on here. I really don't see the reason to do that right now. We'll talk about that on the next slide. I just want you to get used to what the angles look like both in degrees and radians right now. Okay, so let's go back through in blue and let's talk a little bit about conversions. If you took a moment and you converted 150 degrees to radians by multiplying it by pi over 180, you would get 5 pi over 6. And if you want, you can pause for a second right here and just double check that you can get that in your calculator, that you could convert 150 to radians and get 5 pi over 6. If you take 135 degrees and multiply by pi over 180, you would get 3 pi over 4. So that is the equivalent of 3 pi over 4 radians. And finally, 120 degrees is the equivalent of 2 pi over 3 radians. Here's the way I have that memorized, because I'm really not into just memorizing for the sake of memorizing. To me, trig is more about the patterns. You need to know the patterns. Here's the pattern. In quadrant 2, when you convert to radians, notice that all of the numerators are exactly 1 less than the denominator. And the reason for that is that all of these angles are less than pi. This is pi radians here, all the way from here around to here. Well, a little less than 1. Well, if I'm over 6, 6 over 6 is 1. A little less than that is 5/6. This one's also less than 1, but I'm over 4. And so 4 over 4 is a whole pi. So we back down 1 and we're at 3 over 4. And the same thing with this one that has the 60-degree reference angle. Notice again, 30-degree reference angles are always over 6, 45-degree reference angles are always over 4, and 60-degree reference angles are always over 3. That's going to be really important to doing things quickly later on. So let's just make a note of that. In quadrant 2, the numerators, or the tops, are 1 less than the bottom. And that kind of takes care of quadrant 2. So let's put quadrant 3 in. We'll put 3 additional points down here. And first we'll put them in degrees. This would be 210 with a reference angle of 30. This would be 225 with a reference angle of 45. And this would be 240 with a reference angle of 60. So by now, most of you are kind of getting comfortable with the idea that the 30-degree reference angle must have something pi over 6. Now, if the one up here is 1 less than pi, it kind of stands to reason that if I go a little past pi, I'm going to be 1 more than the bottom. So 7 pi over 6. 225, we know is something pi over 4. The bottom is 4. If I'm a little more than pi, it stands to reason that the top should be 5 pi over 4. And then 240, which has a reference angle of 60, has to be something pi over 3 when we convert it to radians. And once again, it's over in the third quadrant, so it's greater than a whole pi. A whole pi would be 3 over 3. And so just moving 1 reference angle past that pushes us into 4 pi over 3. So let's make a note of that down here. In quadrant 3, because it's a little greater than pi, all of the tops are 1 more than the bottom when we convert to radians. Okay, and finally, I know it feels like this is taking forever, but I'm trying to do a fairly decent job of explaining it to you so that you'll have it out there if you ever need to go back and listen to it. Okay, so we're going to put 3 more spots in here. That'll have a 30-degree reference angle. This will have a 45-degree reference angle, and this one will have a 60-degree reference angle. So let's just move through it really, really quickly. This right here would be 330 degrees. This one would be 315 degrees, and this one would be 300 degrees. You should be getting really familiar with those without actually having to think too much about them, especially in the unit of degrees. Okay, so let's see if we can figure out what these might be. This is a little trickier. Well, first off, I know that a 30-degree reference angle is something pi over 6. And this time, I'm almost 2 pi. Well, 2 pi would be 12 over 6. So almost that is 11 pi over 6. 315 degrees has a 45-degree reference angle, so it's going to be something pi over 4 when I convert it to radians. So if I got all the way around to 2 pi, I would be at 8 over 4. With that denominator. So not quite there is 7 pi over 4. And finally, 300 degrees has a 60-degree reference angle, so it has to be something pi over 3. If it were a whole 2 pi, if I'd made it all the way around the unit circle completely, I would have 6 over 3. But a little less than that is 5 pi over 3. So the pattern here, it's a little bit harder to see, but the pattern is that the tops are all 1 less than twice the bottom. So let's write that down. The tops are 1 less than twice the bottom. I know it seems like a lot, but I'm really a firm believer that if you kind of understand the underlying concepts there, that it's going to help you, and especially if you can relate it back to something that's kind of logical. You don't want to spend forever each test as we go further along. And on the ACT, it'll really slow you down. You don't want to spend forever like having to go out and convert some of these from radians to degrees and degrees to radians. It's really better if you can learn to work with the radians as well as the degrees. So that's a good place to stop. That gives you a really good introduction of like the whole unit circle there. And at some point we will take the time to put all of the ordered pairs on as well. But for now, we want to stop right here and we'll pick back up and look at some examples of things we can use these, I don't know, 16 or 17 angles to do.